a slow, meditative descent into the outermost frontier of existence, the farthest reaches the human mind can grasp. Here, galaxies fade into a diffuse cosmic fog, their light stretched thin across billions of years, whispering secrets from the dawn of time. Space itself trembles, stretched and warped by expansion, as if the universe hesitates at the brink of its own becoming. This is not a wall, not a barrier to touch, but a vanishing, a horizon that recedes with every step, a fading veil beyond which the cosmos dissolves into mystery. In this distant realm, the speed of light becomes both guide and limit. Every photon carries a memory, a fragment of ancient history, yet each step outward is a journey backward in time. The stars we see are ghosts of their former selves, fossils of an infancy we can barely comprehend. Observing the universe at this scale is like reading a diary written in light, each page a record of creation, stretched across the vast expanse of spacetime. The emotional tension is palpable. What does it mean for a universe to have an edge? Is it a physical frontier, a limit of observation, a boundary woven into the fabric of spacetime, or an illusion born from cosmic expansion? The paradox deepens with every observation. The universe has no center, no outside, no true border, yet it stretches endlessly in every direction, fading into the void until existence itself seems to dissolve. And in the silence beyond the farthest light, a haunting question arises. If we journey toward the edge of the universe, are we approaching the limits of space, or the limits of understanding itself? Night settles over the San Gabriel Mountains in the early 20th century, laying a dark, velvet silence across the ridges. The winds are still, the desert air thin, and atop Mount Wilson a lone observatory dome opens like an eyelid awakening to the cosmos. Inside, the newly constructed 100-inch Hooker telescope waits, metal, glass, and patience assembled into a single instrument of revelation. It is here, in this cold and quiet place, that humanity will take its first step toward understanding the farthest frontier of existence. The camera drifts through the observatory's interior. Red lamplight pools across the wooden floors. Notes and star charts lie scattered around a desk, illuminated only faintly. The astronomers who gather here have grown used to long nights and colder truths. For centuries, the Milky Way had been perceived as the entirety of creation, a grand, luminous island surrounded by darkness. Beyond it, many believed, lay nothing. But the telescope's eye disagrees. As the camera pushes through the polished glass, the view explodes outward into a field of faint smudges scattered across the night. They were once called spiral nebulae, ethereal clouds, decorative features painted onto the Milky Way's outer canvas. Yet their shapes appear too precise, too structured. Their light seems too old. Something about them whispers of distance, of a scale no one has yet dared imagine. The narration lingers on an astronomer who studies them night after night, a quiet researcher named Edwin Hubble. He moves through the observatory with the calm focus of one who believes the universe still holds enormous secrets. In the winter air, the telescope cools, shrinks microscopically, and sharpens its view. And with each fraction of a millimeter gained, the cosmos grows further, stranger, more immense. A single observation changes everything. One evening, Hubble identifies a Cepheid variable star flickering in a spiral nebula known as Andromeda. Cepheids pulse with an unmistakable rhythm, a beacon used by astronomers to measure vast distances. By studying its brightness, its period, and its faint echo of light, he calculates a number that shocks the world. Andromeda is far outside the Milky Way, far beyond any known boundary of star and dust. It is not a cloud within a galaxy. It is a galaxy itself. The universe expands in that moment, not in the fabric of space-time, but in the fragile landscape of human understanding. The camera drifts outward again, past the glowing dome, lifting above the mountains until the world becomes a blue-black sphere suspended in silence. Beyond Earth's thin atmosphere, Hubble's revelation blooms with cosmic consequence. A universe filled not with one island of stars but with countless archipelagos, each separated by unimaginable seas of void. And with that shift, the notion of an edge becomes far more mysterious. If the cosmos stretches into hundreds of billions of galaxies, Where does it all end? How far does creation extend? But the discovery does not rest there. Hubble examines the light from these galaxies more closely, passing it through a prism to unravel its wavelengths. Many of them appear stretched toward the red end of the spectrum, a cosmic fingerprint revealing motion. The farther the galaxy lies, the more its light is reddened. The universe is expanding. Space itself grows, like a slow breath drawn from the lungs of time. The camera glides through one of these distant galaxies. Stars drift apart like lanterns on an ocean. Their light travels centuries, then millennia, and finally millions of years before crossing the cosmic gulf toward Earth. Every photon carries a story, not of where the galaxy is now, but of where it was when that light began its journey. The deeper the telescope looks, the older the universe becomes. With the expansion revealed, astronomers begin assembling the most profound realization of the early 20th century. If the universe has been expanding for billions of years, then its distant galaxies act like windows into its youth. Their earliest light forms a natural boundary, a horizon of information carved by time itself. No matter how powerful the telescope, its view is ultimately limited by the speed of light. Beyond a certain distance, the light simply has not had the time to reach Earth. Thus emerges the first scientific outline of the observable universe. The narration slows, allowing the thought to settle like dust inside a beam of starlight. Humanity has not discovered a physical border, no cosmic wall or point of termination. Instead, it has discovered a temporal one. A limit defined not by the size of the cosmos but by the age of its illumination. The universe may be infinite, but the visible universe is not. It is a sphere of information expanding outward at the speed of causality. To peer deeper is to look further back in time. To push harder is to approach the dawn of everything. And in the quiet corners of observatories, astronomers begin to realize a truth more profound than any measurement. The edge of the universe is not where space ends. It is where the universe becomes too young, too hot, too opaque for light to travel freely. The chapter transitions to early cosmologists, mathematicians, physicists, and dreamers scattered across Europe and America. Einstein grapples with the implications of an expanding cosmos, discovering that his own field equations predicted a universe that bends, curves, and evolves. Friedman and Lemaitre run the mathematics forward and backward in time, revealing origins that reach into a singular beginning. The camera floats through their diagrams, spirals, curvature lines, expanding metric grids. Their equations shimmer against a digital backdrop, turning mathematics into a landscape. Each symbol pulls the cosmos apart or compresses it back toward birth. For the first time in history, the universe becomes a dynamic story rather than a static stage. The century progresses. Instruments improve. Photographic plates sharpen. New galaxies are catalogued. The observable sphere grows wider, deeper, older. Astronomers no longer search for an edge of space. They search for the beginning of time. Hubble's earliest discoveries plant the first seeds of cosmic humility. Humanity stands on a small, fragile world orbiting an ordinary star in an unremarkable spiral arm of a galaxy that is one among trillions. Yet from this minuscule vantage point, the species learns that its cosmic horizon is shaped not by distance but by the finite speed at which reality reveals itself. The chapter closes with a slow, drifting pullback through the layered shells of the cosmos. From galaxies, to clusters, to dark regions unlit by stars. The narration describes a universe whose edge can never be approached physically, only imagined through light's ancient footprints. It ends where time becomes opaque, where the universe was no longer transparent and photons could not yet roam. In that opaque beginning lies the true frontier, a boundary not of space, but of memory, a horizon carved by the age of the universe itself. A limit defined by the youth of creation. And it is there, in that temporal borderland, that the idea of a cosmic edge first begins to take shape. There is a quiet unease hidden in the starlight. A truth so contrary to instinct that it reshapes the human sense of existence itself. As telescopes grow sharper and mathematics grows braver, the universe reveals something unsettling, something that does not behave like the world of hills and oceans and familiar distances. The cosmos stretches. It breathes. It moves in ways that no ancient sky watcher could have imagined. The chapter begins in a great intergalactic void. The camera glides through a darkness untouched by starlight, a silence so complete it feels older than time. Faint galaxies drift at impossible distances, their light stretched thin by the expanding fabric of space. Their spiral arms unravel slowly, their luminous cores dimmed to embers. This is not motion through space, but space itself lengthening around them. A cosmic tide pulling every island of stars away from every other. As the camera drifts closer, galaxies appear not as isolated beacons but as particles suspended in an invisible current. Their movement is subtle, almost hesitant, yet governed by the profound architecture of general relativity. The farther a galaxy lies, the faster it seems to recede, a relationship Hubble uncovered as a slope on a graph, but one that hides a deeper, stranger truth. The universe is expanding everywhere, simultaneously. This is the first fracture in intuition. In daily life, distance is static. A mountain does not swell. A river valley does not stretch. But on cosmic scales, the rules loosen. Space does not remain fixed, it obeys no rigid frame. Instead, it behaves like a vast, dynamic field, pliable, fluid, ever-changing. Galaxies are not racing outward through emptiness. They are woven into the fabric that stretches beneath them. The narration lingers on the profound consequence of this phenomenon. Beyond a certain distance, galaxies recede faster than light. To an untrained mind, this appears impossible. Nothing may surpass the speed of light. No object may outrun causality. Yet the galaxies themselves violate nothing. They drift calmly within their local space. It is the space between that expands. The universe is not a stage where actors move across a fixed floor. It is the floor itself expanding beneath their feet. The camera sweeps outward, following the faint redshift of distant galaxies. Their colors fade toward crimson, then dissolve into wavelengths too long for human eyes to see. These galaxies do not accelerate of their own will. They are carried by the metric expansion of spacetime, the deep, mathematical framework laid out by Einstein's equations. Here the script pauses to show Einstein's handwritten notes, the stark curvature diagrams, the elegant yet daunting field equations. They float through the darkness like constellations made not of stars but of symbols. Einstein's work reveals a universe capable of bending, twisting, stretching. Yet he himself resisted the idea of expansion. When his equations pointed toward a dynamic cosmos, he inserted a term, the cosmological constant, to stabilize it, fearing the implications of a universe in motion. He later called it his greatest mistake. But the mistake itself carried meaning, because it showed how deeply counterintuitive the expanding universe truly is. The camera sinks into a galaxy cluster. Hundreds of galaxies drift like glowing embers swirling in a calm, celestial storm. Distances between them increase, not because they push each other away, but because the underlying geometry expands uniformly. The cluster remains bound, but the space beyond it stretches into deeper and deeper voids. This realization produces a shock that permeates the early 20th century scientific community. The universe is not eternal and unchanging. It is not infinite in age. It has a history. It has an origin. It is younger in some places, older in others, depending on how long its light has traveled. What once seemed fixed becomes fluid. What once seemed eternal becomes finite. The universe, in all its immensity, possesses a horizon, a boundary shaped not by physical edges but by the limits of time itself. The narration deepens, exploring the emotional dimension of this discovery. Humanity has always lived beneath skies that felt timeless. Stars have appeared eternal, their patterns unchanged across generations. Ancient cultures carved meaning into these unbroken lights. But the expanding universe introduces fragility. Stars are not eternal. Galaxies drift. The sky is not still. The cosmos itself is a restless, evolving entity. The camera shifts to a visualization of the cosmic timeline. Like a river of light, it flows backward from the present. Galaxies shrink. Clusters collapse into early forms. Temperature rises. Density increases. Light becomes trapped in a haze of early plasma. The narration moves with deliberate calm, tracing this timeline toward a singular insight. To speak of the edge of the universe is to speak of the beginning of time. The shock lies not merely in the expansion but in the realization that space and time are inseparable. The horizon is temporal, not spatial. The edge is not a distant wall, but a moment when the universe was too young to allow light passage. A moment when existence itself was opaque. Here the camera drifts into the cosmic microwave background, a faint, mottled glow left behind after the universe cooled enough for photons to travel freely. This ancient radiation becomes a visual sea of soft oranges and blues. The universe is revealed as a child, only 380,000 years old. Beyond this point, light cannot reach. The veil becomes absolute. This is the edge the chapter focuses on. Not the edge of space, but the edge of visibility. A boundary imprinted in the structure of time. Not a frontier that can be crossed, but one that defines the limits of cosmic memory. The narration reflects on Einstein one final time. His equations did not merely describe gravity, they rewrote the human relationship with existence. By linking space and time into a single continuum, he introduced a truth as humbling as it is profound. Every observer carries a horizon. Every vantage point is finite. Every pocket of the universe is bound by what light has had time to reveal. This introduces a philosophical tension that lies at the heart of the scientific shock. If the universe expands indefinitely, its horizons will shrink in informational reach even as space grows larger. Civilizations in the distant future may see fewer galaxies, fewer clues, fewer ancient signals. Their universe will look emptier, older, lonelier. The cosmos we observe today is temporary, fragile, dependent on a brief window in cosmic time when the past is still visible. The chapter closes with a slow pullback across intergalactic space. Galaxies stretch into red lines of fading light. Expansion accelerates. Distances widen. The cosmic horizon recedes. And the narration rests on a single, powerful truth. The universe does not break the laws of physics. It breaks human intuition. In its expansion lies the ultimate humbling revelation. The cosmos began, it evolves, and it carries a boundary shaped not by where space ends, but by how time flows in the long hush between galaxies, where interstellar dust drifts like ancient ash. The universe keeps the story of its earliest moments sealed behind horizons of darkness. Every photon that reaches modern eyes has crossed deserts of time older than the continents, older than the stars that now cradle it. Light becomes an archivist here, a wandering messenger carrying fragile memories from a past the cosmos no longer remembers directly. And yet, for all its reach, there comes a boundary where even light cannot carry the tale any further. Beyond it lie epochs so compressed, so incandescent, that the very act of observation dissolves into silence. Across the centuries, humanity has attempted to bend that silence. With mirrors carved from earthly minerals and detectors chilled to the edge of absolute zero, telescopes became extensions of the universe's own gaze. It is through them that the cosmic night begins to loosen, revealing structures that formed when galaxies were young enough to be counted on a single hand. Infrared observatories pierce through veils of cold gas, radio antennas feel for vibrations older than starlight, and spaceborne mirrors drift above the atmosphere to read the faintest signatures ever imprinted on existence. But even as each new instrument widens the aperture of human understanding, an unspoken question lingers at the threshold. How close can vision come to the universe's first breath? The closer astronomers peer into the abyss, the younger, hotter, smaller, and more turbulent the cosmos becomes, as if the camera is rewinding creation itself. And with every revelation, the darkness at the edge glows a little brighter, inviting yet never fully yielding its final secret. The universe does not reveal its origins willingly. Its earliest chapters remain buried beneath expanding space, stretched thin by time until even light grows faint and brittle. Yet the pursuit of these primordial echoes has shaped the evolution of every major branch of astronomy. What began as ground-based lenses scanning the visible sky gradually transformed into an orchestra of instruments spanning the entire electromagnetic spectrum, each built to uncover a different layer of cosmic memory. The dawn of hidden light. Radio astronomy emerged as the first true expansion of human sight. Unlike optical telescopes that glean the universe through narrow windows of starlight, radio dishes listen to wavelengths stretched so long they behave more like ripples across an ocean of spacetime. In these signals, astronomers discovered entire realms invisible to traditional optics. Jets erupting from supermassive black holes, the faint glow of interstellar hydrogen, and relic emissions tracing the skeleton of the cosmic web. As if guided by an unseen hand, each advance pushed the observational frontier closer to the universe's infancy. The deeper telescopes reached, the more the cosmos appeared to change its face. Galaxies shrinking into irregular clusters, star formation erupting with chaotic brilliance, and radiation thickening like a fog as observations approached the limits of transparency. Infrared eyes in a cold universe. Infrared telescopes added another bridge across time. Where optical light is scattered or absorbed by dust, infrared wavelengths slide through it with patient clarity. Nebulae that once seemed impenetrable now drift open like curtains revealing embryonic stars and the earliest shapes of galaxies stretching back more than 13 billion years. Spaceborne instruments, freed from the atmosphere's warmth, extended this clarity into the deepest cosmological layers. They captured galaxies not yet a billion years old, their light reddened by the relentless expansion of the cosmos. Each photon arriving on a detector represented a journey through epochs when the universe was younger, faster, and far more violent than the serene galaxies of the modern era. The Hubble Deep Fields, a glimpse into youth. When the Hubble Space Telescope opened its aperture toward a seemingly empty patch of sky, the resulting images became a turning point in humanity's understanding of cosmic origins. What appeared as a void resolved into thousands of infant galaxies, smudges of ancient fire suspended in the early darkness. The Hubble Deep Field and its successors revealed a universe only a few hundred million years removed from the Big Bang. Galaxies were compact, turbulent, and ablaze with star formation. Collisions were common, structure was raw. The camera had not merely recorded distant objects, it had captured the youth of the cosmos itself. Every layer in that image functioned as a timeline, the farthest galaxies representing the earliest chapters accessible to light. Scientifically, these deep fields mapped the evolution of structure, showing that the large, graceful spirals and ellipticals of today were sculpted through eons of mergers and gravitational shaping. Philosophically, they offered a profound reminder of how much the night sky hides within its silences. Planck and the afterglow of creation. Yet even Hubble could not touch the deepest frontier. Beyond the era of the first galaxies lies a time when the universe was so dense that light could not travel freely. Photons collided endlessly with charged particles until the cosmos finally cooled enough to let radiation escape, creating the cosmic microwave background, the oldest light we can observe. The Planck satellite was built to map this primordial afterglow with exquisite sensitivity. As it scanned the sky, it revealed temperature differences no greater than a few millionths of a degree. These tiny ripples, anisotropies, are fossils of the earliest fluctuations in density. They carry within them the fingerprints of cosmic inflation, the brief exponential expansion that shaped the distribution of matter across all future time. In the Planck maps, scientists see a universe only 380,000 years old, still glowing from the heat of creation. No telescope can see further with light. Before this epoch, the universe was opaque, a radiant storm from which nothing could emerge unscattered. This boundary, imprinted across the entire sky, represents the furthest horizon of electromagnetic visibility, the true edge of observable existence. A young, restless cosmos. As instruments probe deeper, a consistent pattern emerges. Distance becomes a measure of youth. The further telescopes look, the more the universe appears unfinished, stars ignite with greater intensity, galaxies fracture into chaotic forms, and the temperature of the cosmos climbs sharply. These observations confirm models of early cosmic evolution. Galaxies at extreme distances, visible only through long exposures or gravitational lensing, contain low metal content, high radiation fields, and star-forming regions compressed into tight clusters. They resemble cosmic storms more than the serene spirals familiar to modern eyes. The telescope becomes not merely an observing tool but a time machine, its sensitivity dictating how far the camera can rewind. The layered archive of the cosmos. Each wavelength reveals a different page of creation. Radio telescopes map hydrogen, the universe's first element, outlining the framework of early structure. Infrared observatories pierce the cold darkness of star-forming regions and show galaxies in their earliest stages. Optical instruments like Hubble capture the visible evolution of cosmic architecture. Microwave satellites read the afterglow of the Big Bang itself. Together, they peel open the universe like an ancient archive, each page older and more delicate than the one before. The mystery that remains. And yet, even at the edge of this layered vision, a silence persists. Beyond the cosmic microwave background lies an era no telescope can touch, a realm before transparency, before atoms, before light had the freedom to travel. It is here that inflation erupted, where quantum fluctuations were stretched into the seeds of galaxies. It is here that the first heartbeat of space unfolded. Modern instruments reveal everything up to this boundary with breathtaking detail, but they cannot cross it. The earliest moments remain hidden behind physics itself, sealed beyond the oldest light. The universe, it seems, always keeps one chapter beyond reach, a reminder that even in an age of extraordinary perception, creation still carries mysteries too young, too hot, and too deep for vision to uncover. In the vast hush between galaxies, the universe stretches like a great and ancient breath, expanding, cooling, and drifting into distances so immense that language itself strains to describe them. Light, which once carried the earliest memories of creation, now moves through an arena whose boundaries recede faster than it can hope to reach. The cosmos appears calm to the naked eye, but beneath that quiet surface lies an engine of relentless acceleration. Every second, the fabric of space grows, weaving emptiness between clusters of galaxies, pushing them outward as if creation itself were trying to escape something unseen. Yet as telescopes sharpen and measurements refine, a troubling paradox emerges. The observable universe spans an astonishing 93 billion light-years, a reach far beyond what the age of the cosmos suggests. If the universe is only 13.8 billion years old, how can it be so large? The answer, whispered through equations and satellite data, returns to a single violent instant: inflation, a moment when space expanded faster than light, flinging regions apart before photons could ever link them. But the deeper the measurements go, the more the edge of the universe becomes an enigma. It bends away, not as a wall or a boundary, but as a horizon fleeing at impossible speed. Even now, galaxies drift beyond the limit of influence, accelerated by a mysterious pressure known as dark energy. Their last light will fade long before their forms dissolve, leaving only the memory of their glow etched into cosmic history. The universe, it seems, is pulling away from us, and the chase only widens the gulf. The edge is not a place, but a vanishing act. The universe has always carried an air of vastness, yet only in the last few decades has its true scale become a source of profound existential tension. As measurements sharpened and cosmic maps grew more complete, astronomers realized that the observable universe, everything from which light has had time to reach us, extends an immense 93 billion light-years across. It is a span so large that even imagination struggles to hold it, a width that seems to defy the limits set by the universe's age. Here lies the paradox at the heart of this chapter. How can something only 13.8 billion years old be tens of billions of light-years wide? Inflation, the invisible flinging of space. The answer reaches back to the universe's infancy. In the first fraction of a second, a force unlike anything familiar caused space itself to expand exponentially. This event, cosmic inflation, stretched tiny quantum fluctuations into galaxy-sized patterns and separated regions so quickly that no particle or photon could keep pace. The camera glides across a primordial landscape, where ripples in the early plasma throb like sound waves frozen in time. These fluctuations, magnified to cosmic scales, seeded the large-scale structure of today's universe. Inflation did not simply move objects apart, it expanded the very grid on which existence rests. Galaxies did not outrun light, space carried them outward, like leaves drifting apart on a swelling tide. Because of this early stretching, light traveling toward Earth from the most ancient galaxies follows an ever-expanding path. By the time it arrives, the distances involved have ballooned to incomprehensible scales. The universe is not large because it is old. It is large because space itself has been unfolding relentlessly since the first heartbeat of time. The universe beyond the universe. But the implications run deeper. If inflation happened, and all evidence points toward it, then what we can see is only a tiny fraction of what exists. The true cosmos may extend far beyond the observable edge, a realm so vast that even the word infinite feels inadequate. The camera drifts beyond the reach of any telescope, through territories where galaxies may never be seen. Out here, space becomes an ocean without shoreline, an expanse where the curvature of the universe, flat, open, or closed, becomes a philosophical as much as a scientific question. Even if the cosmos is finite, it is so immeasurably large that no observer trapped in one region could ever confirm it. The observable edge is not the universe's edge. It is simply the boundary of light's patience. The cosmic event horizon, a boundary of fate. Just as powerful as inflation is another, more recent discovery. The universe is not merely expanding, it is accelerating. A mysterious energy, dark energy, is pushing galaxies apart with increasing force. Its presence redraws the map of the cosmos, creating a second boundary, the cosmic event horizon. If the observable edge shows us what light has already delivered, the event horizon defines what light will never deliver, no matter how long the universe survives. Beyond this horizon, galaxies recede so quickly that their future photons will never reach us, not in trillions of years, not across any span of cosmic time. In scientific terms, these galaxies exist. In practical terms, they are already gone. The camera lingers on a lone spiral galaxy drifting toward that boundary. Its light fades slowly, stretched to redness, then to darkness. What remains is not the galaxy itself, but its last whisper of radiation, stranded on the threshold of visibility. A universe becoming empty. As dark energy grows in influence, more galaxies cross this horizon each year. The cosmic web, the great tapestry of clusters and filaments, begins to unravel. In the far future, only the nearest galactic neighbors will remain visible. Everything else will slip beyond reach, as though the universe is intentionally dimming its own lights. This slow vanishing is not destruction. It is isolation. The cosmos is not closing. It is drifting apart, leaving islands of matter in a sea that grows endlessly wider. The universe becomes a place where the past is all that can be seen, and the future is a darkness filled with objects that can never again communicate their existence. The deepening paradox. Inflation stretches the universe faster than light. Dark energy accelerates its expansion into the future. Between these two forces lies a tension that defines our cosmic perspective. The further telescopes reach, the younger the cosmos appears. Galaxies shrink into embryonic clusters, stars ignite in furious bursts, and cosmic temperatures rise sharply. But with each new discovery, the universe's edge retreats faster than instruments can pursue it. Observing the early cosmos is like chasing a dawn that moves away at the same speed one approaches it. The camera drifts toward the edge of the observable universe, a boundary defined not by walls but by exhaustion. Light from beyond this limit simply has not had time to arrive. But even as this frontier reveals younger and younger epochs, the accelerating universe ensures the boundary itself is slipping away faster than any probe, telescope, or future civilization could ever reach. The final implication: if the expansion continues, and all current evidence suggests it will, the universe will one day fall silent. Distant galaxies will disappear from view. The cosmic microwave background will fade into undetectability. Even the nearest structures will drift into isolation, the night sky thinning until only a few faint stars remain. The universe's edge is not a destination. It is a retreat, a vanishing horizon, slipping away faster than it can be chased. A reminder that humanity, for all its instruments and inquiry, occupies only a small island in an ocean whose boundaries move with time itself. In this deepening mystery, one truth grows increasingly clear. The cosmos is expanding not just outward, but beyond comprehension, into regions forever removed from our gaze, our instruments, and eventually, even our imagination. At the boundary between what is known and what can only be imagined, the universe becomes a canvas of speculation. The edge, so long treated as a simple limit of observation, begins to unravel into something far stranger. Here, the laws of physics do not simply describe the cosmos, they reshape it. Horizons emerge not as walls, but as whispers of deeper structures beneath the visible world. The edge is no longer a distance measured in light years, but a question. What lies beyond the reach of light, beyond the map of causality, beyond the birth of time? The camera drifts through a realm where galaxies grow faint and the cosmic microwave background dissolves into a curtain of ancient static. Beyond this veil, mathematics takes the place of measurement. Theories bloom like constellations in the darkness, inflationary planes stretching into infinity, quantum fields humming with latent energy, universes budding like droplets on an eternal ocean. In this frontier of the mind, the edge becomes a mosaic of possibilities. Perhaps the universe is infinite, its curvature flat as an endless sheet. Perhaps it is closed, curving upon itself like the surface of a higher dimensional sphere. Perhaps it stretches open with a gentle negative curvature, carved by forces we have yet to name. And perhaps, in a far more unsettling vision, the cosmos is only a temporary state, balanced precariously in a false vacuum, waiting for a quantum tremor to rewrite its destiny. These theories do not compete, they coexist like overlapping shadows, each offering a different interpretation of the horizon's true nature. The edge of the universe becomes not a place, but a question folded into the fabric of existence. As telescopes reach deeper into space and computers simulate epochs never seen, the edge of the universe transforms from a simple observational boundary into one of cosmology's greatest philosophical puzzles. Science discovers not one answer, but a constellation of theories, each grounded in mathematics, each painting a different cosmic architecture. Inflation, a universe that outgrew its light. The camera glides into the first fraction of a second after the Big Bang, into a realm where physics strains under unimaginable energies. It was in this primordial instant that physicist Alan Guth proposed a radical idea. Inflation, a period when space expanded exponentially, doubling its size again and again in a fraction of a moment. This theory explains why the observable universe looks uniform, why galaxies trace delicate filaments rather than chaotic structures, and why the cosmic microwave background carries patterns stretched almost beyond recognition. Inflation implies something extraordinary. What we see is merely a small patch of a universe grown far beyond light's ability to reveal. The edge becomes a relic of inflation's amplitude, a horizon that marks how far its afterglow has traveled, not the actual size of the cosmos. In this view, the universe may be enormously larger, perhaps infinite, its true regions hidden behind a curtain of cosmic acceleration. Eternal inflation, a cosmos of endless bubbles. Some models push Guth's idea further. Inflation may not have ended everywhere. It may continue eternally in vast regions beyond the observable universe. Here, space swells continuously, birthing pockets where inflation slows, and each of these pockets becomes a universe with its own physics. This is the multiverse hypothesis. The camera sweeps across an imagined sea of expanding space, dotted with luminous bubbles. Each bubble holds a universe, some with strong gravity, some with no atoms, some dark, some short-lived. This grand cosmic froth stretches in every direction, its boundaries expanding faster than light, its regions forever isolated by eternally inflating space. In this framework, the edge of our universe is not a cosmic border. It is simply the boundary of our bubble. Beyond it lie countless others, unreachable and forever sealed behind accelerating expansion. The edge becomes a membrane separating one region of physics from another. The shape of the universe, geometry as destiny. Einstein's general relativity allows space to curve with matter. This curvature, too subtle to see with the eye, defines the universe's ultimate architecture. There are three possibilities. 1. Flat universe, infinite and unbounded. The camera glides across an endless cosmic plane where galaxies stretch toward infinity, never looping back. Observations from the Planck satellite suggest our universe is astonishingly flat, its geometry balanced with exquisite precision. If perfectly flat, space may have no edge at all, just boundless continuation. 2. Closed universe, curved like a hypersphere. Imagine space curving into itself in a higher dimension, like the surface of a globe extended into 4D. Travel far enough, and one would return to the starting point, not because of walls, but because of curvature. The edge becomes a loop, a cosmic circle without boundaries. 3. Open universe, a saddle of endless expansion. Here, space curves outward with negative curvature. Galaxies drift ever apart, never bound to return. The edge becomes a region forever expanding, carving deeper into infinity. Each geometry reshapes the meaning of edge, transforming it from a location into a feature of cosmic topology. False vacuum, a universe living on borrowed energy. Quantum field theory introduces a chilling possibility. The universe may not be in its lowest energy state. It may exist in a false vacuum, a metastable energy level, stable for now but not forever. Picture a marble resting in a shallow dip atop a greater valley. It may remain still for eons, held by chance. But a quantum fluctuation, a tiny tremor, could send it rolling into the deeper valley below. If our universe resides in a false vacuum, the edge could mark the boundary of this metastable state. Beyond it, a more fundamental vacuum may exist, separated by immense energies. A collapse from false to true vacuum would rewrite the laws of physics, particles, forces, spacetime itself. In this theory, the edge of the universe may correspond not to distance, but to a frontier of energy, a threshold separating what is from what could be. Einstein's horizons, where information vanishes. Einstein's equations reveal something profound. Horizons occur not only around black holes, but in any space that expands too rapidly. These horizons do not block matter, they block information. Just as a black hole's event horizon marks a point beyond which nothing can return, the cosmic event horizon marks a limit beyond which no information from the expanding universe will ever reach us. The edge becomes a horizon of causality, a place where time, space, and information untangle and lose meaning. It is not a physical boundary but a limit of knowledge, a point where the universe moves beyond communication. A constellation of possibilities. Cosmic inflation suggests a universe far larger than what is visible. Eternal inflation hints at a multiverse. Geometry offers the prospect of curvature shaping destiny. False vacuum theory casts the cosmos as unstable, poised on the edge of transformation. Einstein's horizons define boundaries of knowledge rather than matter. Each theory reinterprets the edge of the universe not as a physical endpoint, but as a geometric boundary, a causal horizon, a quantum state, or a relic of inflation's early violence. The farther science reaches, the more the edge dissolves into abstraction. The edge as a concept, not a location. The universe may have no physical border, only horizons woven into the structure of spacetime. The edge becomes a map of our limitations, defined by how far light has traveled, how fast space expands, and how deeply physics can probe. Perhaps the edge is not something humanity will ever reach. Perhaps it is something it must understand that the furthest reaches of the cosmos, where the faint glow of the first stars drifts like embers through the darkness, humanity has learned to look not with feet but with eyes forged from light and gravity. The edge of the universe is not a cliff or wall, it is a whisper of ancient photons, a murmur of gravitational tremors, a subtle curvature in the cosmic fabric. To approach it, instruments must become extensions of human imagination, telescopes that see farther, detectors that feel the universe's vibrations, and theories that stretch the mind into the primordial night. The camera drifts past the nearest clusters of galaxies into the dim glow of the cosmic dawn. Here, the first structures began to collapse, igniting the universe's earliest stars and heating the intergalactic medium in a process called reionization. The light from these stars, stretched and reddened across billions of years, carries with it the secrets of creation, encoded in faint photons too subtle for ordinary instruments to detect. And yet, with every new generation of observatory, these whispers grow louder. From spaceborne infrared eyes like the James Webb Space Telescope, capable of peering into galaxies less than a few 100 million years old, to future radio arrays mapping the 21-centimeter line of primordial hydrogen, humanity is assembling a toolkit to touch the universe's earliest chapters. Gravitational wave detectors sense ripples in spacetime itself, the echoes of inflation's rapid expansion. Quantum theories hint at edges hidden not in distance, but in the very structure of space and time. The edge of the universe is no longer an abstract horizon. It is a frontier actively probed, measured, and mapped. And as instruments sharpen their gaze, we realize that the hunt for the cosmos' true boundary is as much an exploration of knowledge as it is of space itself, a pursuit of the ultimate silence where the universe began. The universe cannot be chased in a ship, nor touched with hands. Its boundaries, real or conceptual, must be approached through light, gravity, and the mathematics of fundamental physics. In the 21st century, humanity has assembled an unprecedented fleet of instruments, each designed to pierce deeper into the cosmos, to look backward in time, and to uncover the processes that shaped the universe's earliest epochs. James Webb Space Telescope, Eyes on the Cosmic Dawn. The James Webb Space Telescope, JWST, represents the culmination of decades of ambition. Its mirrors, 7 times larger than Hubble's, are cooled to cryogenic temperatures to capture the faint infrared glow of the first galaxies. Here, the universe is no longer a static backdrop. It is an infant, chaotic, luminous, and unstable. JWST's observations aim to push beyond the epoch of reionization, revealing how the earliest stars ignited, how the first galaxies assembled, and how light began its journey across expanding space. As the camera drifts through Webb's simulated deep fields, each faint galaxy is a fragment of memory, a relic of a time when the universe was less than 1 billion years old. Through these glimpses, scientists hope to approach the universe's edge as it existed shortly after its birth, a boundary not of distance, but of time. Euclid Mission, Mapping Dark Energy. While JWST peers backward, the Euclid mission surveys the present universe with an eye toward the future. By mapping the distribution of galaxies across vast distances, Euclid tracks the influence of dark energy, the mysterious force accelerating cosmic expansion. Its precise measurements of galactic clustering and weak gravitational lensing will reveal how structures evolve and how the cosmic horizon is being stretched outward. Through Euclid, astronomers quantify the dynamics that cause the universe's edge to recede faster than light itself. The edge becomes not a place, but a consequence of an invisible push that shapes the fate of all galaxies. Vera Rubin Observatory, charting the cosmic web. The Vera Rubin Observatory, with its wide-field optical survey, provides a complementary approach. By tracking billions of galaxies across time and space, it constructs a 3-dimensional map of the large-scale structure of the universe. This map illustrates the cosmic web, the network of filaments and voids sculpted by dark matter and dark energy. Observing this structure is akin to reading the universe's memory of expansion. The farther the filaments extend, the more distant the horizon that separates us from unseen regions. The Rubin Observatory's nightly sky sweeps ensure that even transient cosmic phenomena, supernovae, tidal disruptions, and lensing events, are catalogued, adding depth to our understanding of the universe's evolution toward its farthest observable edge. Gravitational wave detectors, listening to spacetime. Beyond light, another frontier emerges: gravitational waves. Instruments such as LIGO, Virgo, and future space-based observatories like LISA can detect ripples in spacetime from the universe's earliest moments. Inflation, the hypothesized exponential expansion of space, should have left an imprint, a background of primordial gravitational waves. Detecting these signals would reveal the dynamics of the universe at fractions of a second after its birth, effectively opening a window onto epochs beyond the reach of light. Here, the edge is not measured in kilometers or light years but in events, vibrations of spacetime itself, carrying the signature of creation. 21 centimeters cosmology. Hydrogen as a cosmic ledger. Looking forward, 21-centimeter cosmology promises another revolutionary view. Neutral hydrogen emits a faint spectral line at 21 centimeters, which, when redshifted by cosmic expansion, allows astronomers to map the cosmic dawn, the period before the first stars fully reionize the universe. Future arrays, such as the Square Kilometre Array, SKA, will attempt to trace this hydrogen across the universe, charting its earliest structure with unparalleled resolution. Through these observations, scientists hope to glimpse not just the youngest galaxies, but the conditions of space itself before starlight had yet to traverse the void. Quantum gravity research, probing the fabric of reality. Finally, some edges may not be observational but conceptual, embedded in the very fabric of spacetime. Theories of quantum gravity, including string theory, loop quantum gravity, and holographic principles, suggest that space and time might themselves be quantized or have a minimum unit. In these models, the edge of the universe could be a property of spacetime's microscopic structure rather than a distant horizon. By simulating black holes, early universe dynamics, and high-energy interactions, theorists hope to uncover whether spacetime is continuous or discrete, and whether causal or geometric limits define a fundamental boundary of reality. The edge, in this sense, is no longer just an observational horizon, it is encoded into the quantum architecture of existence itself. The philosophical implication. As instruments multiply and theories refine, a pattern emerges. The pursuit of the universe's edge is as much an inward journey as an outward one. The edge is not a place we can reach with rockets or probes. It is the limit of light, of causality, of information, and perhaps of space itself. Each tool, WST, Euclid, Rubin, gravitational wave observatories, 21 centimeters arrays, quantum simulations, extends the boundary of human comprehension. With every photon captured, every wave detected, every simulation run, the universe whispers its earliest secrets, allowing us to approach, inch by inch, the horizon where time began. The hunt for the true boundary is a testament to human curiosity, a patient, careful, and relentless effort to witness what lies beyond the veil. And yet, the edge always remains just out of reach, a reminder that the universe is larger, older, and more mysterious than imagination alone could encompass. Beyond the faint shimmer of the farthest galaxies, beyond the whispers of the cosmic microwave background, the universe stretches into a silence that is older than thought itself. There is no wall, no cliff, no ultimate boundary to touch or fall from. There are only horizons, shifting, retreating, defined by the finite speed of light and the inexorable expansion of space. Each photon that reaches us is a messenger from the past, carrying fragments of memory from epochs we can scarcely imagine. To gaze at them is to look not just outward, but backward through time, toward the universe's own awakening. The camera drifts slowly across interstellar voids, where clusters of galaxies float like scattered jewels in a black ocean. Each point of light is both familiar and distant, a testament to the patience of nature and the audacity of curiosity. Humanity stands on the edge of understanding, peering across a horizon we will never reach, yet striving to convert these ephemeral signals into knowledge. The edge becomes more than a physical concept. It is a metaphor for our own search, the boundary where ignorance gives way to discovery, where wonder becomes inquiry, where questions bloom into the pursuit of truth. In this silence, there is humility. The cosmos reminds us of scale, fragility, and the fleeting nature of perception. Yet there is also beauty, a quiet affirmation that in our effort to see, measure, and understand, we participate in the universe's ongoing story. The edge is not a limit to despair, but a threshold of possibility, a reminder that exploration itself is an act of courage, patience, and awe. The edge of the universe, as humanity understands it, is not a tangible location. There is no precipice, no wall, no signpost marking the boundary where existence ceases. There are only horizons, sculpted by the finite speed of light and the expansion of space, retreating perpetually as time flows. These horizons are profound not for their obstruction, but for their invitation. They mark the outer limit of what can be known, the border of visibility, and the frontier of curiosity. Cosmic humility. The first lesson of the edge is humility. Each photon that reaches us has traveled billions of years, emerging from galaxies that may no longer exist, from epochs when the universe was young, hot, and unfamiliar. These photons carry the signatures of cosmic infancy, revealing patterns of stars, galaxies, and intergalactic gas shaped by forces beyond direct perception. To interpret them is to confront the vast scales of space and time, to recognize that human life is brief against the backdrop of cosmic evolution. By contemplating these horizons, humanity is reminded of its place in the universe, small, ephemeral, yet capable of understanding. There is awe in realizing that the universe has been evolving long before any observer existed, and will continue long after. The edge, unreachable and retreating, offers no dominance, only perspective, a call to patience and respect for the cosmos. The edge as a metaphor for curiosity. Yet the edge is not merely a lesson in humility, it is a beacon for curiosity. Science is the art of extending perception, of turning faint signals into knowledge. Every telescope, every detector, every theoretical model acts like a hand reaching toward the horizon. James Webb's infrared vision, Euclid's mapping of dark energy, gravitational wave observatories listening to spacetime itself. These instruments transform distant photons and ripples into understanding. In this sense, the edge is not an end, but a process, the perpetual challenge to comprehend the incomprehensible. The edge embodies human curiosity in its purest form, an ever-receding frontier that cannot be conquered, yet compels us to explore. With each new observation, the edge retreats, revealing subtler structures, stranger phenomena, and deeper questions. It is not a place to arrive, but a state of mind, a reflection of our enduring desire to reach beyond the immediate, to map what has never been touched, to see what others could not. Time, fragility, and wonder. The horizons of the universe are also mirrors of time. When we observe the farthest galaxies, we see light emitted billions of years ago, illuminating the cosmos as it once was. The edge becomes intertwined with temporal perception, the limit of causality, the frontier where our observations meet the dawn of creation itself. It is both an end and a beginning, a threshold where ignorance gives way to knowledge, yet reminds us that some mysteries may always lie beyond. In these distant fields, there is solitude. Galaxies drift apart, the cosmic web stretches thin, and dark energy silently accelerates expansion. Humanity is an observer in a vast, patient cosmos. The emotional undercurrent is subtle but persistent, wonder at the universe's beauty, fear at its vastness, and a quiet humility at the recognition that we are both participants in and witnesses to its unfolding story. The edge and human meaning. The edge also prompts philosophical reflection. In contemplating the unreachable, we confront the limits of our understanding and the fragility of perspective. It invites questions about existence, purpose, and the nature of reality itself. The edge is a metaphor for exploration in all domains of human thought, not just astronomy, but science, philosophy, and art. It represents the pursuit of truth in the face of uncertainty, the courage to ask questions for which answers may be partial or forever elusive. Yet there is also unity in this pursuit. Every photon captured, every gravitational ripple analyzed, every model refined links humanity to the cosmos. Observers on Earth become interpreters of the universe's narrative, weaving insights into a tapestry of knowledge that spans generations. The edge, though physically distant, connects all who look outward with a shared sense of wonder and responsibility. The edge as beginning. Ultimately, the edge of the universe is not where space ends, it is where understanding begins. Horizons retreat not to deny knowledge, but to encourage pursuit. Each new discovery, Each instrument, each observation extends the frontiers slightly farther, transforming impossibility into comprehension. The edge exists to challenge, to provoke reflection, and to inspire the next generation of explorers. In this quiet dialogue between human curiosity and cosmic vastness, the edge becomes poetic. It is the place where observation meets imagination, where physics meets philosophy, where awe meets inquiry. As instruments sharpen, theories deepen, and understanding grows, humanity finds itself not at a limit, but at the threshold of discovery. Closing reflection. The universe is infinite in scale, eternal in duration, and patient in silence. Its edges, whether observational, theoretical, or philosophical, are not threats but invitations. They are a reminder that the cosmos is larger, older, and stranger than we can yet grasp. And in pursuing its horizon, humanity participates in the universe's story, turning distant light into knowledge, isolation into connection, and mystery into purpose. The final thought lingers as the camera drifts through an intergalactic void. The edge of the universe is not a wall. It is the frontier of understanding, a symbol of curiosity, and a testament to the human spirit. It is the quiet whisper of photons from the dawn of time, guiding us ever forward into the infinite.